Good afternoon, everyone. Thank you for joining us. If you have any questions throughout the presentation, please put them in the chat box and we will answer them at the end. We will also send out the slides and recording of this webinar afterwards. I'd like to introduce our speaker today, Sarah Geiger. Sarah has been working with Spex Sample Prep for the last 12 years in sales, marketing, and customer service roles. She enjoys working with customers to problem solve their sample preparation needs while learning a little bit about their applications. Sarah, please take it away.
All right. Hello, everyone. Thank you for taking the time out of your busy days and schedules to listen and learn a little bit about sample preparation. I would also like to say thank you to Midland Scientific for the opportunity to speak. As Paula mentioned, my name is Sarah Geiger, and I've been with Spex Sample Prep for the last 12 years. I've helped out in all different areas in marketing, sales, and now is my key role as an equipment specialist. Okay, so today what we're going to do, we're going to talk about a brief history of the company. They're going to go over a little bit of the cannabis workflow, and then we're going to discuss. We're going to discuss the importance of sample preparation. We'll go over some of the equipment that can help with these challenges that you'll find, and then then we'll have some time for questions afterwards as well. Okay, so Spex Sample Prep Group was founded in 1952. It consists of Spex CertiPrep, which is our certified reference material company, as well as they do standards and different things like that. In 1954 was when the sample preparation portion of the company was founded, and with about 68 years worth of experience, we've learned a few things about sample preparation. In the beginning of 2020, we were acquired by Cole Parmer, which is now Antilles Scientific, which is a part of the, so we're a part of their Spex line now. So this is a picture of our 10,000 square foot facility. This is where our manufacturing takes place. All of our equipment and accessories and orders are shipped out of. And that includes our lab, our order processing, and R&D and different things like that. So this is basically where the bulk of our company actions take place. So with everything is assembled here in the United States in our facility in New Jersey. The nice thing about that is that if you have a question about the equipment, about your applications or anything like that, there is somebody around here who can help. So feel free to contact us if you do have anything. Okay, so a little bit about the cannabis workflow. First, I would like to let you know that I am not a scientist. I have on-the-job lab training focused on different experiences I've had when I've done in-person demos and different things like that, and from talking to the customers. What I've mainly focused on is basically turning your initial samples into a powder or a goo so that way they can be analyzed. I always joke that I'm the powder and goo girl. So anything beyond that, I tend to leave to the experts. So like I said, this is a general overview of the workflow for the cannabis. So you want to take your samples, you need to homogenize it. So whether it's get it down into a powder form for the edibles or be able to do your cell lysis for your plant materials, you're going to do your target isolation, whether it's acid digestion, solvent extractions, or using DNA extraction kits. And the different things you're going to be testing for are your heavy metals, pesticides, cannabinoids, your solvents, terpenes, pathogens, and DNA purity as well. The end machinery is different things along the lines of your spectroscopy, your GCs, GCMSs, ICPs, and HPLCs, or your PCRs and different equipment like that. Like I said, just a quick overview of the process. But what we're here to talk about is what exactly is sample preparation. Sample preparation, it's kind of simple. It's the act of homogenizing the starting sample into an analytical form, what I like to call powder or goo. The concept, it's not complex. However, it is often the most overlooked step throughout your entire workflow. However, it is also the most important step. Let's take a look at some of the examples that are pictured here. You've got your gummy candies that do not like to homogenize or particle size reduction at ambient or room temperatures. The easiest way to do that is freeze them and then pulverize them. Your oatmeal raisin cookie is made from at least 6 different types of ingredients. Anything from, you've got the oats, you've got sugar, you've got flour, you have your raisins, and they're all different consistencies and they all grind differently in different ways like that. So freezing it and pulverizing it again is going to be the easiest way to get a homogeneous and consistent particle size. And then you have it's a similar thing with like the Rice Krispie treats and the dog treats. The flour, you've got all the different, you've got your leaves, you have the oil, it's a very oily consistency and different things like that. So each type of sample proposes its own different, its own different challenges in getting down to, like I said, the particle size or the, sorry, I'm losing my words here today. Particle size, or to get it down to that homogeneous state, so that way you can do your analyzation. Now, there are many different reasons to homogenize. A lot of times you're taking a look, or you're looking to create a uniform representative sample. A representative sample from the larger batch of product, such as a field of plants or a batch of an edible product. And you want to be able to get a uniform representative sample of the entire whole. You're looking to be able to get the sample into a form so that way it'll be able to be read by the GCMS, the ICP, or the HPLC. Or another example would be if you're looking to do like DNA, you need to be able to grind and get down to the DNA. So you need to do the cell lysis in order to reach that before you can put it into the PCR machine to be amplified. You're also looking to test different types of, you're looking to test different types of things, for example, pesticides or potency, mycotoxins or metals. The key is to have reliable and quality analysis based on the sample preparation technique. There are several different factors that are going to affect your results. The main idea is to make sure that everything is well represented, because if you have contamination or different things like that, the best spectrometers will give you poor results if the sample preparation is poor. When collecting samples from a larger whole, for example, like the farm, it's important to ensure that the population is represented accurately. You don't want to just grab all of the plants, your leaves from one plant. You want to make sure you grab from different portions of the harvest to make sure that it is an overall representation of that. The goal is you want accuracy and precision, and mechanical grinding is the safest way to guarantee those results. So what type of concerns are we talking about, and how can mechanical grinding help? The first concern is consistency. Is it going to be the same from sample to sample? Are you hand grinding? Are your results, because with hand grinding, your results are going to vary from the beginning of the day to the end of the day due to fatigue. Is more than one person going to be grinding the samples? Because if I were to hand grind, it's going to be different than the person next to me and the person next to them, just because of different strength and, again, fatigue, and maybe someone didn't get a good night's sleep the night before. Are you using the same types of solvents every time, or are you using different batches from different companies? Are you measuring everything out? If you're working with edibles, are the final particle sizes similar? Is it the same from from cookie to cookie or different things? Remember we were talking about that. I mentioned the oatmeal cookie. Are all of those ingredients ground down into a fine powder so that way you're getting an accurate representation of everything that's in those samples? Mechanical grinding can help resolve that. Another thing you're looking to do is you want to eliminate contamination. I've been in labs or talked to people who are using blenders and mortar and pestles and coffee grinders, or the handheld licers that are they kind of look like milk frothers. I mean, are you cleaning the samples? Are you cleaning in between each sample so you are 100% sure that there is no trace of contamination left until your next sample? Is there any foreign bodies that are mixed in with those samples? By using vials and grinding media, the equipment can help eliminate that type of contamination. The next thing that you're concerned about is you want to use increased throughput, and you want to make sure that your speed and you're using an efficient use of time. Are you grinding by hand where you're only able to process one sample at a time, or are you able to prepare a few samples and then run them in the machine? Because this is where sample preparation tends to be where a bottleneck of the process happens, because you're weighing out each sample, you need to grind each one before you can put it in. Whereas in some of the downstream steps, you can grind them in batches, or you can process them in batches. And the same thing with the equipment, but are you doing it one at a time, or are you doing multiples at once? As I mentioned before, it's like there are other companies that are using I've heard of labs, like I said, that are using coffee grinders and are using like bullet blenders or the mortar and pestles, where you're dealing with contamination. It's a low throughput. You're getting variable results, again, from grind to grind, because there's not as much consistency. So the main goals that you're looking to do with sample preparation, you're looking to get reliable results. You want quality analysis. You want it to be duplicatable and reproducible. You need consistency within your grinds and within your testing from one batch to the next. You want to be precise. You want to eliminate your contamination. You want thorough extractions, and you want to be efficient with your use of time. Okay. And then we want to try to keep it simple. As you can see here's some before and after pictures of homogenization when using, I believe we ground hemp in those vials, where everything looks the same. You have the same amount of sample, it's the same color, it's consistent across the board. With the particle size reduction with the brownies and the gummies, although that is a picture of the ground brownies right there. But you just want to make sure that everything is ground to a fine powder, so that way when you do your extractions, everything is reliable. So what solutions do we have? So the Spex sample prep Geno grinder, this is probably we're going to actually talk about my two favorite pieces of equipment that we have. The Geno grinder is our ultra high throughput homogenizer. This is designed specifically for plant tissue and animal tissue. There are a couple other things that you can use in there as well, but right now we're focusing on plant tissue. So what's nice with this, it's such a flexible unit. You can run anything from tighter plates up to 50 ml format. And then, as we were getting into the cannabis market, we had more and more states that were just like, all right, well, we need to be able to grind 50 50 grams worth of flower at one time. So we now offer 12, 16, and 25 ounce jars where you can process 25-ounce jars at one time with this unit with the correct adapters. It works in an up and down motion, so that way it's a consistent grind across the board. The unit itself has a touch screen where you can program the machine, so that way once you figure out what your protocol is, how fast the machine is running and for how long, you can then save it. You can call it 50 grams, 10 grams, depending on what you're working with. What's nice with this unit too is if you're working with 50 ml tubes, which tends to be one of the between the jars and the tubes, the 50 mLs tend to also be the most popular. You can run up to 16 tubes at one time, and we're actually working on a larger clamp that will be able to do more than that as well. So that is on the horizon. So this is an ultra high throughput. I always let customers know that it's probably going to take you longer to load your samples than it will to process them. Most flour is ground within about 2 minutes of grinding with the machine, and it's down to a beautiful powder. As I mentioned, the different types of formats that it can do. You can do room temper or chilled with the use of cryo blocks. Some of the other markets that we're involved in is we've got cannabis, food and agriculture. You've got your biotech, your pharma. We're in government, a lot of government settings as well, including environmental and academic settings. We do also have 2 lower throughput models for the labs that are only doing a handful of samples at a time. We have our mini G, which can do about 6 50 ml tubes at one time, just to give you an idea of the difference in the throughput. And as you can see, there's only 2 controls. It has an LCD screen. It doesn't have the LED programmable screen. With this, and then the next unit, this is designed specifically for edibles. This is probably, for me, one of the most fun instruments that we have, because you never know what you're going to be asked to grind, and this unit will pretty much grind it. So anything that will not grind at ambient temperatures, like for example, the cookies, the gummy bears, we can grind a batch of gummy bears in about 45 seconds in the freezer mill. Not including the pre-cool time, and I'll explain how the machine works in the next slide. So you can store up to 20 protocols with this as well. It has what sets this unit apart is the fact that your vial is grinding directly into a bath of liquid nitrogen. So your sample inside the vial is coming in contact with liquid nitrogen, which is what is making it so cold and brittle, and why we're able to get the powder that we can. Each grinding chamber can hold one large vial, which is about the size of a 12-ounce soda can, and can hold anywhere between about 50 to 100 grams. One mid-sized vial, which is about the size of like a Red Bull can. 4 of the small vials, which can do about 1 to 5 grams worth of sample. It's about the size of a cigar, and the micro vials are going to be too small for anything that you're doing. They're about the size of a Bic pen. And the different types of things you can use this for, like DNA extraction, and for something like I said, anything that's not those ambient temperatures where it needs to be frozen. This unit is fantastic at grinding things like plastic, or if you're doing cartridges, if you have to do anything like inhalers. It's metals can be a little difficult depending on, because I know there's some of the cartridges have like metal components. It just depends on the type of metal. Like I said, plastics and different things like that, it will be able to grind. So how this machine works, like I said, there's a bath of liquid nitrogen. You're going to take your sample, you're going to put it into the vial. As you see, there are 2 metal end plugs and that rod in the middle. And that's actually what is doing the grinding. There are no moving parts. With this, we use magnetics to draw that bar back and forth, and that is what does the pulverization. And that is how you get the powder. Or what you want to do is you want to start with a pre-cool, because you want to give the samples a chance to get down to those liquid nitrogen temperatures. So it'll take 5-10 minutes, where, like I said, you just want to do that. We do have cooling chambers in the freezer mills, so that way while one set is grinding, you can have one set chilling, and that actually helps with the throughput as well. And just to give you guys an idea, here are some before and after samples. So we've got some mixed nuts as well as a cupcake. There is some flour there as well, Jolly Ranchers, and then gummy bears. The one thing that's really interesting with gummy bears, if there is one red gummy bear, the entire sample is going to end up being red. And I always find that very interesting, because that works with just about any of the candies. That red dye is very powerful. Let's see. So as I mentioned, we are a part of the life sciences group with Antilia Scientific. So just real quick. So the different things that we also offer is, like I said, I mentioned Spex CertiPrep with the certified reference materials. We also have PCR, chromatography, and spectroscopy as part of the line as well. And that's pretty much what I have. I was not expecting that to be 22 minutes. So you guys will get some time back, depending on how many questions you have. So hopefully I didn't confuse anybody. And that's something.
Thanks, Sarah. That was a great presentation. If anyone has any questions, you can either unmute or put them in the chat box. Otherwise, we will send out the slides as well as the recording of this webinar. And if you have any questions there, you can reach out as well. Looks like we got a question in the chat. To eliminate or minimize contamination, do you suggest any specific reagent grade?
That again is unfortunately not something that I'm familiar with. What I generally recommend is, when you're as far as contamination, when you're washing the samples, or if you're washing, because the freeze-drill vials you reuse, so when you're using those, you want to make sure that the stainless steel end plugs are going to be autoclavable. So either that, or you can wash them with a 10% bleach solution. And the same thing with the polycarbonate center cylinders. You just want to be careful. You want to make sure that any of the solvents that you are using are friendly with polycarbonate, because polycarbonate typically does not play well with others.
Awesome. And then another question was, what are the cost ranges for different procedures? We might need to have a rep follow up if you don't have that answer.
Yeah, I was gonna say that would be a question for your Midland Scientific rep.
Perfect. I will connect them together. If we don't have any other questions, thank you everyone for joining us, and thank you, Sarah, for the presentation.
Thank you again for having me.